Here's a good example. We have to find the kinetic and thermodynamic products of this addition reaction. First of all, let's decode this. What is a kinetic product? That just means the product that is formed faster. The thermodynamic product is the product that is more stable. First, let's figure out the kinetic products. So, the compound that is formed faster is the one with the transition state that has the lower energy, so that there's a lower activation energy. So here's what we're going to do. We're going to look at the first step of this reaction, and we're going to form a carbocation intermediate, and there's going to be two resonance structures for that intermediate. So let's look at those. Here our double bond is breaking, and the bromine is taking these two electrons here. And that hydrogen would go on at the end so that a secondary rather than a primary carbocation would be formed. So this is one resonance structure, but we could move electrons like this and find this other resonance structure. So the bromide really has two choices about where to add. It could go here, or it could go here. When the bromide attacks this carbon here, the transition state has a lot of positive charge on that carbon, and that is a secondary carbocation. Compare that to when the bromide attacks this carbon, then a lot of the positive charge is on this tertiary carbocation, and that's a more stable situation. So in the first situation where the bromide attacks this carbon, the energy goes maybe like this to a transition state. But in this situation where the bromide attacks this carbon, the transition state is more stable, so lower in energy. So the addition to the tertiary carbocation is that's going to happen faster because there's a lower activation energy here. This distance represents that activation energy compared to this distance for adding to the secondary carbocation. So the kinetic product would be this product here. This is the 1,4 product, where the hydrogen was added to this first carbon, and then this is the fourth carbon over here where the bromine was added. Let's see what the non-kinetic product would have been. It would have been this 1,2 addition product. So now let's think about the thermodynamic products. Which one of these is the thermodynamic product? Well, it's the one that's more stable. To figure out which one's more stable, we just figure out which of these double bonds is more substituted. And it's this one. So the 1,2 addition product is the more stable, lower energy thermodynamic product here. So let's follow an energy diagram for both of those addition products. Starting with the intermediate, this carbocation intermediate, we determined that the 1,2 addition has a unstable transition state and a stable product. But the 1,4, and this is the 1,2 here, the 1,4 has a more stable transition state and a less stable product. Here's a cool thing. You can control which products are made by controlling the temperature. In a high temperature environment, there'll be a lot of molecular motion, and if the 1,4 is formed, the molecule can kind of realize its mistake and go backwards over this activation energy barrier and reform the intermediate, and then go the more difficult way to get the more stable product and stay down here because there's a big activation energy barrier to get back and reform the intermediate from that. But if the temperature is cold, a lot of this kinetic product is going to be formed pretty quickly, and there won't be enough molecular motion being cold to jump over this activation energy barrier to reverse that formation and go back to the intermediate. So there stays a lot of kinetic product if it's cold.